Welcome to Numberth and to the Animate Maths podcast. My name is James, and as always, I'm joined by my less talented and less attractive acquaintance, Sam Cordan. This podcast is about putting the fun in fundamental maths skills. We will discuss specific maths concepts with contexts, models, questions, and games that can be used in schools or at home. It's aimed to educators. It aims at educators, in fact, but everyone is welcome to listen in if they want to. Most of what we discuss can be found on our ever-growing website that Sam Cordan does, but James doesn't have a say in it because he can't be bothered. www.adamupmaths.c_to_the_m. Happy listening! !
Oh no.
Go.
We've got to do this in 20 to 30 minutes.
Okay.
Because in that time, 2 children will be coming back to make lots of noise.
Okay.
And you've got to go to bed.
No, I haven't.
Okay.
It's not that late. Sam,
Okay.
What are we talking about today?
Well, it's another one of my favourites. They're all my favourites.
Yeah.
It's fractions of amounts or fractions of quantities.
Right.
You excited?
Yes, because Thomas is doing fractions now.
It's funny, isn't it? We say we're doing...
One of the questions which I'll put to you is, as a starter, what is 2/3 add 1/4?
You want me to answer it now?
Yeah, go on then. May as well. Go straight in. Immersive.
This is not our focus. We're not doing adding fractions. Fractions are so big. But if you want me to do it,
Yeah.
2/3 is the same as, we've got to change to 12, so 8/12, and 1/4 is 3/12. So it gives you 11/12 altogether.
You didn't explain that very well. You didn't. To someone like me who needs a visual, you didn't explain that very well.
You put me on the spot, and already out of my head, we were doing fractions of amounts.
Yeah.
It's a very specific part of fractions, and then you've just opened up with all of fractions and adding. I wasn't prepared.
It was a time of war. It was a time of famine. It was a time of redemption. It was Adam Up Maths. And they were putting the fun in fundamental.
What I want to talk about first, I think, is this is a classic thing where you might end up with a rule. To find 3/4 of 50, you divide 50 by the denominator and then multiply by the numerator.
Yeah.
And I think this is one of these rules where being able to understand it first is really important. Really, really important. Whereas some concepts you might go with the process first and then understand why. I would definitely start with the understanding with this one. Okay. So it's knowing what the denominator means and what the numerator means.
Okay.
Building it from there. So, I mean, I don't know if you want to do this bit now or stick to our normal routine of
Let's do it now.
About context. Do it now.
Let's do it now. Let's do it now. By the way, you keep making a funny noise. Are you clinking something?
I don't know.
Is it static? What is it? Move around a bit. Yes. Can you hear it?
No.
You've got a creaky chair?
No. I'll try and keep still.
Okay.
Just get nervous movements when I talk to you.
There's definitely there's quite a loud noise that's happening. Anyway, carry on. Just keep still.
I'll try. I'll just move my mouth. Keep everything else still. Right then.
I wish I was behind you and do the arms. That'd be good. And try and get a cup of tea and a biscuit.
Yeah. Oh, that'd be good. I don't drink tea, but I could do with someone to help me out with some water occasionally.
Okay.
Let's start with an easy example of 1/4 of 20.
Okay.
Let's not put any context in or anything yet. It's just a quarter of 20. And it's understanding, use that a quarter is when you are, so we've got to be a little bit careful, haven't we? But a quarter is when you're sharing or splitting something into 4 equal parts.
Yeah.
Yeah. And so drawing a bar model, yes. You look like someone from like a Dr. Seuss character with your hair like that. Like, out the Grinch.
It's all right. I'm not listening to Sam, by the way. I'm just making my hair stick up in the end. We have probably got 17 minutes.
I've got about 18% of battery left.
Okay, let's go. Let's go.
Okay. Right. So I want you to imagine you draw a rectangular block. For anyone familiar with the bar model, you know where I'm going. If not, a rectangular block.
Yes,
and that full block.
Yeah.
Oh, yeah, sorry. And that full block is worth 20.
Yes.
You with that so far? The full
it's
block.
Worth 20.
It's worth 20. That is what it represents.
Do I need to draw 20 lines within it?
No. Just one block, and the whole thing is worth
20. Okay.
The amount of it is 20.
Worth 20 what?
Well, it could be £20, $20, 20 kilograms, 20 jelly beans.
Got you.
Whatever you want. And you want to find a quarter of that.
Yeah.
Then you would split your bar into 4 equal parts.
Okay.
So you've got your rectangular block, and now you're going to chunk it up into 4 equal sections.
Okay.
And then you sort of you talk about how that each of those sections is worth a quarter.
Mm-hmm.
Good. Okay. And then you'd say, well, what is the value, or what is the quantity, or however you want to phrase it? What's the money amount of each of those boxes?
Okay.
4 boxes. Each is an equal amount, and it's got to make 20 altogether.
Okay.
So can you think what that would be in each box?
Well, I'd have to do 20 divided by 4, wouldn't I?
Absolutely. Yeah.
Could I do the inverse to find out a whole? I'm jumping ahead.
I think you keep it simple. So if some students will recognize 20 divided by 4 is 5.
Yeah.
Each quarter of 20 is worth 5.
Yeah.
And some might do it by trial and error. You might say, okay, I'm going to try putting 3 in each box. 3, 6, 9, 12. No, that doesn't make 20. So it can't be 3 in each box.
Yeah.
Anyway, let's say you got to 5. Then 1 quarter of 20. Visually, you can see it's worth 5.
Yeah.
And then you can start to look at when the numerator is not 1. So if you had 3 quarters of 20,
yeah,
you then can say, well, that's going to be the value of 3 of those boxes.
Yeah.
Each box is worth 5. So 3 quarters of 20 would be 15.
Okay.
And then what I recommend doing there is you try that with several different questions, different problems. You could start to bring a bit of context in as well. And then try and encourage everyone to generalize. So that's where you might start to say, oh, well, actually, if you're doing 3 quarters of 20, you're taking your 20, you're dividing by 4, and then you're timesing that by 3.
Mm-hmm.
And then you might start to generalize. So you're starting with your amount, your full quantity, you divide by the denominator, and then multiply by the numerator. And hey presto, you're done.
Okay, so let's bring it right back.
Oh yeah.
Oh yeah.
All the way back to the beginning of time.
One of the for me, the person who explained fractions best was my dad, and he explained it with pizzas. Yes. Pizza slices, and that kind of made sense to me. But the way when I've taught students at my school who have a kind of an introduction to fractions, I found the most effective way is to use Numicon. We're plugging Numicon.
Again?
Yeah, again.
I think they should start paying us royalties or something.
If you take your... well, I like it because... it's shapes and colours as well. And if you took yours, I suppose you wouldn't start with something as big as that, but a quarter of 20, then you'd take the two tens, stick them together to make one big rectangle, and then find the numicon that fits in 4 times.
Oh, yeah, that's good.
But I think I'm jumping ahead here.
Well, like I said, fractions are so big, and before this, you'd really start exploring what a fraction is and fraction of a unit. So you're talking about pizzas, and then you're saying that you split a pizza into 4 equal parts, each is worth a quarter. And I think it might be worth doing a different podcast on the origins of fractions. But I was just quite excited to talk about this one because I've been
fractions.
teaching.
I mean, like the first thing you could possibly do is just look at the word in the dictionary. Because a fraction is a piece of something, I guess, isn't it?
Yeah.
Part of something.
I think it's good to come up with your own student-friendly definition because those dictionary definitions are a little bit.
All right.
Yeah. I missed a word.
Yeah.
I couldn't think of a word.
Mature. Advanced.
Mature.
2 people from different worlds, but very much connected. Adam at Maths, putting fun in fundamental.
I want to gain a bit of control here because you're going off on one.
No, I'm not.
Tell me about context. We talked about pizza.
Oh, right. Yeah, like what we normally do to start with. Yeah. So pizzas are good, cakes are good, chocolate bars, and I think that's an interesting thing because those are our 2 default ones, like a circular way of showing fractions, pizza style, cake style, and then you've got your chocolate block style, the kind of rectangular bar model almost that we've talked about already.
Yeah.
I think both are valid, both work well. I think it can get a bit trickier. Perhaps if you're doing something like sevenths or fifths, when you're using circles, it's a bit harder to try and split that up. Whereas if you had some squared paper, you're working in a traditional maths book with squared paper, it's quite easy to draw a block split into fifths because you can use your squares to do it. So
yeah. In the past,
I've taught
quite often side by side with time, reading a clock.
Yeah. Oh, well, yeah. I mean, there's a big link there with quarter past, which we never really think about. That's just because it's a fraction of the hour. Yeah.
Yeah. So circles are always, for me, would be the go-to starting point for halves and quarters because they've got to understand that kind of abstract terminology as well, haven't they? So,
yeah, there's also a big argument for number lines as well, because we often forget that a fraction is just a number as well. So if you think about your number line with integers, or 0, 1, 2, 3, 4, and so on, and starting to notice where a half would be on a number line, and 3.5, and a quarter, and stuff like that. Not necessarily straight away, but part of the fraction package. It's a good tool.
Okay.
Yeah.
What I've done in the past, and I am moving on a little bit, if that's okay, but we're aware of time, but I'll be very quick, is similar to what I've done in the past with units of measure. So you get loads and loads of units of measure and examples like kg and g and ml and all that kind of stuff. And then they've got to create a picture with it. So print out A4 big diagrams of that stuff, and they've got to create a big picture. And it's a way of finding out which ones are similar and which ones are different, and they categorize them. You could do that with fractions as well. I am moving ahead here, but things like fractions and time link, fractions division link, fractions and percentage. So maybe doing something like that to start off with.
I just want to take this opportunity to say how much you've evolved as a practitioner over the years, because these are wonderful ideas, which would never come out of your little mouth before.
I haven't taught maths, Sam, for probably about 7 years.
I don't think we should be telling our viewers.
Oh, sorry. But I observe it.
Yeah, you watch from your ivory tower and you watch your little minions at work.
Yeah.
No, you're not like that, really, are you? Would you like me to give you my add 'em up context?
Yes.
Okay, so this is my little story. And I actually did this with one of my groups at school last week. And it goes like this. Adam and Millie come to a bridge. So just for our new viewers, our new listeners, Adam is Adam up, Millie is Millimeter, and they're on an adventure to find Adam's mother, Anne Gull, who's mysteriously disappeared in this place called the Land of Problems. So anyway, they're on their journey, and Adam and Millie, they come to a bridge where they meet an old man. And the man says, "You'll be careful as you go across the bridge. There are evil goblins that live under there. However, there is one thing you could do, and that is to feed them magic jelly beans." So, yeah, that's what they have to do. They've got to give them, if they feed them some jelly beans, then they'll be able to get it across. Now, the man, though, the Land of Problems is not a place where everyone's friendly. He's not going to just give them some magic beans and let them go.
Can I stop you there?
Yeah.
Are they magic jelly beans or normal?
Yeah, I said both, didn't I? I don't. What do you think? What do you want?
Gotta be magic, haven't they?
Yeah. So anyway, he's got 3 bags.
Yeah.
He's got 40 beans all together.
Yeah.
And one of the bags he's put 3/8 of the 40 beans.
Yes.
And in the second bag he's put 2/5 of the 40 beans. And in the third bag he's put the remaining beans, the ones left over. So he says, "I advise you choose the bag that's got the most beans, because you just don't know how hungry these evil goblins are going to be." And so the question is, which of the 3 bags should they choose, and why?
What sort of magic do they possess? Does this come into play?
Nah, but why not? Maybe.
Could they multiply?
Oh, that could throw a whole other dimension into this problem. If that happened. Maybe they talk, or maybe they fly. Maybe they pop out of the bag and little wings and just drift into the goblin.
How much percentage battery you got?
Yeah. Oh, let me check. Oh my goodness, 14.
Oh,
14.
Goodness me. Okay, right. Okay, let's get on. How do we solve this problem, Sam?
Well, yeah. So I would encourage the class. Well, again, it depends when you're going to do it. If you're doing it after you've taught something already, then I would encourage them to use that bar model. Or if they come up with their own method of saying divide by the denominator, multiply by the numerator, and go through that way. It might be, if you're doing it at the very beginning, it's literally a bit of a guess, just looking at those fractions, what do you see? And you might think that some might go for 3/8 of 40 beans because it's got bigger numbers in, because 3 and 8 are larger. Whereas actually, it's the 2/5, which is the correct answer.
Okay.
Yeah. But I mean, that's just our fantastical context. And there's so much you can do with money and measures. And that's a really good way of bringing measures alongside the number stuff as well.
Okay.
Time for our song?
Which song? There are 2 songs.
So the one we're going to use today is the Fractions of Amounts song,
Okay.
with the one with the holy man who comes down from the sky and says, "Children of number." That one?
No, we got 3 fraction songs actually. Yeah, go on in.
Yeah.
Here is. What's the title?
It's the Fractions of Amounts song.
Children of number, is there anything I can do to help in this time of brotherly love?
Well, sure thing. I don't know my halves, my thirds, my quarters, nor my fifths. Can you help? 1/2, 1/2. What do I do
To find 1/2, divide by 2.
1/3, 1/3. 1/3.
find 1/4, divide by 4.
1/5, 1/5. Do you still divide?
Yes, that's right. Divide by 5.
1/2, 1/2. What do I do?
To find 1/2, divide by 2.
1/3, 1/3. What about me?
To find 1/3, divide by 3.
1/4, 1/4. Tell me more.
To find 1/4, divide by 4.
1/5, 1/5. Do you still divide?
Yes, that's right. Divide by 5.
Can I just pick your brains on the inspiration for making it holy, and what was in your mind when you created this one?
I thought that was you.
Well, no, I
didn't-
came up with the lyrics. I came up with 1/2, 1/2. What do you do to find a
Oh,
half?
it's just
divide by
themes, isn't it? It's like, in my head now, I'm thinking, if I had to suddenly come up with a song now, I'd think, right, we haven't done cavemen. So, we do cave, and I probably just thought we haven't done religion. so there you go. That's probably.
As I don't know if you've seen, you probably haven't because you're not that interested, but the newer version of the video. Have you seen the newer version of the video?
No. Is it any good?
It's really, really good. So the old version just had the lyrics, and it was just the little number crunchers coming up to the vicar or the reverend.
Yeah.
And that was it, really. But now there's a bar model etched into the cathedral. Well, that's not really a cathedral, small chapel.
Yeah.
So it's bringing that bar model that we talked about already, the rectangular block, to show how you can use that to work out a fraction of a quantity.
Mm. Do you mind if I just chip in here with an idea that I'd had?
Always.
Just very quickly, because we're probably on about 12% battery.
Yeah.
I observed a lesson today, greater than and less than and equals or the same as. And it got me thinking about, you could do something with this when you're representing fractions. So you like your counters, don't you? Your red on one side, yellow on the other side.
I do.
And you could do 4 counters with with one red up and 3 red and 3 yellows facing upwards. And then you could do is greater than or less than, and then you could do, 3 counters and 1 yellow, for example. So you're visualizing greater than and less than, which goes into your goblin context story. It kind of feeds into that. What do you think?
That's it. Well,
Just because you want to know which bag has the most jelly beans.
I
can-
see what you're saying. So
you can visualize
the 2 results. Yeah. Yeah. You brought it all back, and I think it's.
And you don't even need to use counters. You could use jelly beans, or you could use, I don't know, anything really.
Even better.
Mm.
Yeah, actually, do you know what? I hadn't crossed my mind. That's a really good way to. So that interleave, I think, is a word people like to use nowadays. Interleaving previously taught ideas in with new ideas. So you can bring in their comparison. Interleaving. Oh, it's a cringy word, isn't it? Interleaving with the new stuff.
I'll tell you what else is a new word. It's not differentiation anymore.
Oh,
It's adaptation.
No.
Yeah. I prefer it. I think it makes more sense. Adaptation is I think is a better word because it's more inclusive. So it takes into account, let's say, for example, students who use a wheelchair in PE, or students who are have English as a second language, maybe, and differentiation doesn't really fit in with what you're trying to do. Adaptation, I think, is far more how do you adapt your resources, your teaching, your time. And I think that's much better. Anyway, we're going off piece. So where were we? We've done context, haven't we? So you've done your story.
We kind of did our models as well.
Yes,
already.
We've done models. So unless you want to add models.
No. I've got 11%.
Yeah, it's like I can't hang around with you. It's like you're hanging around with my mates. So like, and I'm at maths anyway. And I'm at maths. Put the fun and fundamental.
Questiones. Launch questions. Okay, so they're following up from that song, Fractions of Amount song. So these launch ones are just, for our new listeners, just questions from what you. This one is 1/2. What do you do? ... Complete the line. So that'd be to find a half, divide by 2, or something along those lines. And then just a couple of the questions that were seen on the video. So half of 60 appears on there. So that would be a couple of launch ones. Happy?
I'm very happy with that.
Yeah. And autopilot are just your basic fluency kind of questions. So it's things like just what is a quarter of 20? What is a fifth of 30? Maybe throw in one where the numerator is not 1, so not a unit fraction, something like what is 2/5 of 30 as well. Okay. So again, it's just sort of building up that confidence with the skill.
Yeah.
And then, can you remember what the third category is? You can do it.
Huh?
I believe in you.
Is it magic jelly beans?
It's the hyperdrive.
Oh, of course it is. Of course it is. What I'm going to do, you don't know this yet because I'll edit afterwards, is I'll do like a launch question and there'll be like a launch sound effect.
Oh, that'd be amazing.
And then hyperdrive, I'll do a hyperdrive sound effect.
Ooh,
context is going to be difficult.
I have to say, at this point, I couldn't be bothered. Sorry. Maybe next time.
Okay, some hyperdrive questions. Perry. Now, Perry is perimeter. Anyway, Perry says that a quarter of 20 is 80 because 4 times 20 equals 80. Do you agree? Give a reason. So that's one thing. Fill in the missing number. 4/7 of something equals 44. So there's a classic kind of missing number question there. So you're not looking for what comes after the equal sign traditionally that we do, but putting that missing number within the number sentence for the first part of it.
Yeah.
And then how many fractions of quantities can you write which have an answer of 28? For example, 1/10 of 280 equals 28. Try and include some decimals, maybe even some negatives.
Like that. If you don't know about negatives, look at the last podcast.
Oh, if you want to go on an odyssey of epic proportions, then listen to the Negative Numbers podcast.
Yeah. Can I throw in just something that is a popular question, I think, amongst teachers? Should you be encouraging students to be thinking to link division in terms of sharing and grouping with fractions or not?
Oh yeah, well that's kind of what it is really. We're talking about right back to your pizzas. If you're going to be thinking about a quarter, it is division, isn't it? You're splitting that pizza into 4 equal parts.
And you have passed the test. Well done.
Oh,
That one.
I was thinking
what I was
the other
actually
day
saying
about,
was, should
oh,
you?
God.
But I didn't do
Yeah.
that intonation to make it sound like a question.
Well, no, I think that's actually a really good point, because fractions can seem so alien and separate. It's like, how often do you hear children and adults say, I can't do fractions, yet many will say, I can do division. And it really is.
And many
so-
can share stuff out every single day.
Yeah.
So in terms of going back to like practical, contextualized stuff, it is something that we do all the time without even knowing it. It's just that when it's written down, that's the abstract thing. It doesn't kind of make sense, does it?
No, and when you get to your things like your adding fractions, like a third, like your one you started with 2/3 plus a quarter, and you get all sorts of misconceptions. And I think that's the part where it starts to become, I can't do fractions, because you get these quite abstract rules and things you have to remember lots of.
Atom up maths, putting the fun in fundamental. 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 Putting the fun in fundamental.
James is deep in thought. He has his hand resting on his chin.
Can you hear that
Index finger
dog?
Yeah,
Can
I
you
did
hear that
actually.
dog? Oh, it's
I've
really,
got a dog.
really annoying.
Oh, it's your neighbour.
Next door. Anyway, there it is again. As you know, I'm a famous recording artist, and
Yeah.
quite often when I do my vocals, the dog comes out and starts to bark away. It just ruins it all for me. I have to sing my lyrics really quickly.
Yeah. It's like having only 10% battery left, isn't it? Oh,
Yeah.
9%.
Oh, okay.
Rocket Fuel is a game that I've made, which is on the website, and the website is
www.adamatmaths.com.
Yeah, good. And it's, you got the rocket, and you have to fill up the fuel. You got to so it can go on its journeys. Now there are 3 fuel tanks within the rocket. Each of them has 60 little parts to it. And what happens is you roll 2 dice, and let's say you roll a 3 and a 4.
Magic dice.
Magic dice. They can fly and they can talk. Yeah, and they can 3 and a 4, and you make the fraction 3/4 with those numbers. Now, you can't make the fraction 4/3. It has to be either 1 whole. So if you've got 2 4s, you could have 4/4 as a whole. That's fine. But you can't have anything over the whole. So let's say 3 and 4, 3/4. Then you will colour in 3/4 of that first tank.
Right.
And then so it's a race kind of with another person. So you've both got the game board, then the other person has a go. Let's say they get 2 and a 5, and they colour in 2/5 of the first tank. And you can overflow from one into the other, except for the final tank, where you have to get that completed exactly. And
No, I shouldn't be putting people off our resources, but for me, I think it's a fantastic visual game. You will need a new piece of paper for every single game you play, though.
well, it depends if it depends if you want to laminate it or not, because you could laminate it and use a whiteboard pen.
You could do. Oh, he's clever. So I'll tell you what, the amount of times I used to go past Mr. Cordan's class and they were all doing colouring.
Come on.
I've just got to catch up on my PPA work.
Yeah, come on.
No, I'm joking.
Colouring
I am joking. I am joking. Crosswords.
8%. 8%.
8%. What's that in fraction? 8 hundredths.
Very good.
Bring it down. 4 50ths. Bring it down. 2 25ths. That's as far as we can go.
Keep it there.
Keep it there.
Yeah.
Could you go further? Could you go 1 13.5?
Well,
No, 12.5. Could you do that? One? No, you
it's-
can't. Can you do that?
No, you don't
Yeah,
mix
you could.
decimals. with-
Yes, you could. But could you? But could you?
No. No.
No, you couldn't, because the one wouldn't be one, would it? No, you couldn't do that.
No.
Okay.
No.
I got too confident there.
You really enjoyed yourself, weren't you? And then you just took it
Yeah.
a little bit too far.
But I like to ask the questions that nobody else likes to ask.
And I think that's why this format works so well. Oh my goodness, the battery sign has got a flashing cross on it now, which I've never seen before. I've never let it get down.
Does that mean it's good? Is it giving you a kiss?
It does look like it. It's flashing. It's going.
Lots of kisses. It's congratulating me for my 120 12.5s. Anyway, go.
Funny enough, the moment you said 1 over 12.5, 1 12.5, it started flashing. So I think it's a warning sign. Don't do this.
Sam,
Anyway,
what have we got left to go?
I just want to give a quick shout out to my Year 12 maths group, who I've found are quite avid fans of the show. A quick shout out there.
Great.
I don't think we've got time for any problems or puzzles today, or maybe even any comments. But is there anything you want to add?
But I would like to say, the person who might be one of your Years 12 students who said something about Sinkostan, I think that's a really good idea still.
It was a different one.
Oh, was
it was a different student, but yeah, I think
that person come up with the lyrics, and we can put it into song and video. I'm quite happy to do that, as long as it's clean.
That is how charitable we are as an organisation, aren't we?
Yeah, and lazy.
Yeah, we've done too much. We're getting too old.
Oh, tell you what I would like to say before you go. If you like this podcast, or if you don't like it, can you share it, please? And apparently you can rate it on Spotify. Don't rate it 1 or 2, just rate it 5 out of 5.
Yeah.
If you're not going to do that, just don't even bother. Just 5 out of 5 or nothing. All right.
And I'm thinking we need to start getting some guests on the show.
We do. I know the first guest to get.
Oh, keep it a secret. We don't want to. Or do we want to?
He lives in the woods. His name's Bill. He's a withered old man with a crooked walking stick. And
he has bags of magic beans.
Magic bean? No, he's not. There's a guy called Cliff who runs a company called About Face, and they're like a diversity, inclusivity group. So it won't be sort of maths related, but I think it's really important. There's lots of amazing things he talks about, like whitewashing and stuff like that, and in the curriculum. So I'd like to get him on.
Oh, okay.
Is that okay?
Sounds interesting. Yeah.
Cool. All right.
Very good.
Great.
All right.
Or that either him or Ricky Gervais. I haven't decided yet.
Adam of maths, dude. Like putting a fun in fundamental, dude. Rad.
Right then. How much battery?
Right. We're going to finish today on 6%.
Can we not keep talking till it goes?
Does anyone else? Is that what you wanted to do?
Yeah.
Keep going to. What? Did you get any questions? Are there any questions that anyone sent in today?
Okay, bear with me. I'm just going to locate it now. Okay, so I've got one from Bilbo, and he lives in the Forest of Dean. And Bilbo says, are the numerator and the denominator the same?
Well, first of all, yeah, it must have been hard to find a way of writing this when you live in the middle of the forest. Was it some with charcoal or something?
Probably doesn't live in the forest. I mean, he's got Twitter for a start. I got distant family who lived in the Forest of Dean.
Oh, okay.
I remember going fishing with Forest of Dean, and we were digging for worms, and I was digging away, and I'd hit this sack, and I realised I was digging up this old lady's old dead cat. Anyway, that was in the Forest of Dean. Yeah.
Is that true?
Yeah, that is true.
Oh my goodness. Anyway, so Bilbo has got access to modern technology.
Yes.
despite living in the middle of the forest.
Yes.
And he's asking if numerator and other things. Well, by definition, they are different. You know, we've talked about this a lot, and we know you want to rewrite maths by getting rid of those words from history. Denominator refers to the number of equal parts. The quantity or the whole is broken up into, whereas the numerator defines the number of parts you are choosing. Now, there is obviously an example where you have them equal, so 4 quarters. You're splitting let's go with pizza again, into 4 equal parts, and you would be eating or choosing 4 of them.
Yeah.
But they're not the same things. So even though those numbers are the same, they refer to different things. So that, one is how many parts are you splitting it up into, and the numerator is how many parts of that are you taking or eating. Do you think Bilbo will be satisfied with that?
I think so, but I very much doubt he's hearing a response.
I get the impression Bilbo is someone who doesn't really care about what the answer is. He just wants a bit of fame. You know, he's going to get a question out there, and he's been broadcasted on one of the most popular educational podcasts out there, and he's got what he wanted. But hopefully the answer's given him a little bit of joy and satisfaction as well.
Fantastic. Okay. We just got one more. This is from Loudon the Third.
Loudon
the Third. And he says,
hang on a sec. Is that the Loudon the Third from Estonia?
No, it's from
a different one.
No, from Saltley. And he says, if you halve a piece of paper in the middle, and then you open it up, you've got 2 halves. Is that the same if you go from corner to corner? You halve it from corner to corner. Is it still a half?
Oh, that's a very good question, Loudon. Well, it depends on what your paper was to start with. If it's a square piece of paper and you fold it from diagonally, I don't know if my hand actions are doing anything to help. You look.
No.
Then you split it in half, because each of those 2 parts are equal size.
Excellent, brilliant.
Is that enough?
I think that's enough. I think I'm imagining Loudon was talking about a square.
Oh, okay.
Yeah.
So it's back to the definition. The definitions are knowing that a fraction is when you're dealing with equal parts.
Can you cake in half the piece for me and you? The numerator is 1 and the denominator is 2. Can you cake in half a piece for me and you? The numerator is 1 and the denominator is 2. I'm a numerator and I'm sitting on top of a fraction, and the denominator's looking straight up at me. I'm a numerator and I'm sitting on top of a fraction, and the denominator's looking straight up at me. Can you cake in half a piece for me and you? The numerator is 1 and the denominator is 2. Can you cake in half a piece for me and you? The numerator is 1 and the denominator is 2. I'm a numerator and I'm sitting on top of a fraction, and the denominator's looking straight up at me. I'm a numerator and I'm sitting on top of a fraction, and the denominator's looking straight up at me. Can you cake in half the piece for me and you? The numerator is 1 and the denominator Can you get half a piece for me and you? The numerator is 1 and the denominator is 2. I'm a numerator and I'm sitting on top of a fraction, and the denominator's looking straight up at me.
Don't forget to visit adamupmaths.com for completely free resources, tons of songs for every concept you could possibly think of, tons of worksheets and games and things like that. And it's all free because we don't know what we're doing. Bye! Say goodbye.
Well, yeah, see everyone. Thank you.